Hey everybody, my name is Mike Marzano. I am one of your CS 1371 TAs, and I would like to take some time to go over the repelm function for a couple reasons. One, because it's super useful, and I'm not sure the professors are going to be able to get to it since it's an exam week. And two, because you're going to need to use it for one of your homework problems, or rather, it's going to make one of your homework problems a lot easier. So let me go ahead and share my screen and we can begin. So, replm is a function that stands for replicate element, and it is the best way to stretch a vector. So its form is nuvec equals replm, that's repelem, parentheses, the vector you want to stretch, comma, and the amount you want to stretch that vector by. Now, amount can have two different values. The first is a scalar, which replicates each element that many times, or it can be a vector of the same length as your first input, and it will stretch each element in vec by the amount in the corresponding place in your second input vector. If you're confused, don't worry, we'll go through an example. So first, let's go ahead and stretch a vector by 3. So if we say, let me clear stuff because we don't need any of this. Cool. Change current folder. Bingo. So let's go ahead and stretch vec. So let's say long vec is equal to replm vec, comma 3. Cool. And we won't suppress it. So let's go ahead and run this. And you can see that long vec now has each element replicated 3 times. So we have 5, 3, 1, 4, 2. So now we have 5, 5, 5, 3, 3, 3, 1, 1, 1, 4, 4, 4, 2, 2, 2. Pretty simple, right? Super easy and convenient. So now let's go ahead and stretch each element a different number of times. So I have given those number of times in this variable up here amount. So it's going to be the first element is going to be replicated twice, the second element 3 times, third element 4 times, fourth element 5 times, fifth element 6 times. So let's try this. Longer vec is equal to replm by vec of amount. And we will run this. And now we can see that long vec, each number has been replicated a different amount of time. We now have 5, 5 replicated twice, 3, 3, 3, 3 replicated 3 times, 1, 1, 1, 1, 4, 4, 4, 4, 4, 4, and then 2, 2, 2, 2, 2, 2. All right? So hope that makes sense to you guys. Now, you may be wondering, like, okay, that's neat. How would I actually use that? So let's go through a quick example, application example. So say we have a bunch of states that are listed right here. So we have a bunch of states. And what we want to do is we want to delete all instances of Georgia from the string states. So first thing would be finding, and we're going to do this using masking. And so first thing we'd do, it'd be finding the instances of Georgia in this string. Now, we know that Georgia is unique because it is the only state that starts with a G. So all we have to look for are capital Gs. So this is going to be, so first we need to do is we need to just find all the capital Gs. Let's shrink this down into just the first letter so we can look for only the capital Gs. So this is going to be one letter is going to be states of, we want 1 in steps of, so 1, 1, 2, 3. So steps of 3 to the end. So now if we run this, we see that one let is now the first letter of each thing. So we can now say mask is equal to states equals capital G, and we now have a mask for each, we now have a mask for each of our thing, and we see that our mask is a 1 by 30, and, not states, we want to look at one let. There we go. That looks like a much better length. So now what we do is now we have a true everywhere that there is a G. But what we need is a true everywhere there is a GA space. So really, we need to take each true here and replicate it 3 times. So we can now say mask is equal to mask of replm of we want to say mask is equal to replm of mask, comma 3. So now, when we run this, we see that our mask has been replicated, and so since now we can use this to actually delete. We can say states of mask is equal to goodbye. So now we save this and run this, and we now see that states has removed all instances of Georgia. So I hope that makes sense. So now let's go another application example. So let's say we have some vector, and we need to sort this vector. So we're going to sort it in descending order, but then we need to stretch this vector so that way each element is replicated to the number of times of that value. So let's take our original vec, which I'm going to copy down here just so that way we can see it. So now what we want to do is we want to we want to sort this in descending order, so we're going to have 5, 4, 3, 2, 1, and then we want each element to be replicated by its value. So we want 5 5s, 4 4s, 3 3s, 2 2s, and 1 1. So let's go about this. So first thing we need to do is sort. Since we are just going to be dealing straight with the vector, we don't have to have a second output for our sort function. We can just sort vector in descending order. Cool. Let's double check and make sure it does that. Hey, cool. Our vec is now in descending order. So now we can replicate our vector equals replm vec. So now each element in vector is going to be replicated the number of times of that element. So we can run this, and we now see that 5 has been replicated 5 times, 4 has been replicated 4 times, 3 has been replicated 3 times, 2 2 times, and 1 just once. So that is a quick overview of repelm. I hope it's been helpful. The important things to take away from repelm is that you can replicate by a scalar, you can replicate by a vector, but they have to be the same length. And the other big takeaway is that repelm works on data types other than just double. So as you saw during our first application, we stretched a mask. repelm will also work on character arrays, or character vectors, cell vectors, and structure vectors. So I hope this has been helpful for you, and best of luck on your homework.